Hello, today we're going to have a look at tree diagrams and we're going to go on to using them to calculate probabilities. They're really helpful for considering more than one event. So it might be two separate events, or it might be the same event happening on two separate days or on two separate occasions. So if we run through example 1, and then I've got a question for you to have a go at, and I'll tell you to pause the video when necessary there. So the probability that Colin is late for work on any given day is 1/5. Draw a tree diagram and find the probability that Colin is late on exactly one of 2 days. So what I'm going to do is I'm going to label the first set of branches as the first day and the second set of branches over here as the second day. So the probability that he is late on the first day is 1/5. So he's either late or he's not late. There are only 2 options. So late or not late. The probabilities that he's late is 1/5. The probability that he is not late is 4/5. And so we would determine this by doing 1 take away a fifth, which is 4/5. Another way to think about it is think, what's the difference between this 1 and 5? The difference is 4, so your numerator here will be 4. And that might be a helpful way to think about it. He could be late on the first day, and then on the second day, he could be late again. I'm just going to rewrite the second day there. He could be late again. Again, that's with a probability of 1/5. Or he could be not late on the second day, and the probability there is the same. He could be not late on the first day and then late on the second day, and that probability that he's late stays as 1/5. And he could be not late on both of those days. And again, that probability there will be 4/5. Now I can use my tree diagram to calculate different probabilities. So for example, here where I'm asked to calculate the probability that he is late on exactly one of the 2 days, he is either late and then not late, or he is not late and then late. So to calculate the probability that he is late and then not late, we multiply across. So we've got 1/5 times by 4/5. And remember, with fractions, we times the top and times the bottom, so that would give you 4/25. The probability that he's not late and then late, well, again, we times across, so that would be 4/5 times 1/5, which again would give you 4/25. And because it could be either of these options, so it could be that he's late then not late, or not late then late, we add these together. So the probability, I'll just do this underneath, that he is late on exactly one day is equal to 4/25 plus 4/25, which would give me an answer of 8/25. So hopefully there the process of completing the tree diagram makes sense, and then you can see here how we would use that to calculate probabilities. So what I'm going to ask you to do now is just have a look at the your turn question. I'll read that through for you. So it says Rachel plays 2 games of chess. The probability she wins any given game is 0.3. Draw a tree diagram to find the probability that Rachel wins exactly one of the 2 games of chess. So if I just show how we would draw that tree diagram, we've got game 1, she either wins or she does not win. And then game 2, again, she either wins, does not win, wins, or does not win. And we are told that the probability that she wins any given game is 0.3. And remember that each set of branches, so these branches, and then these 2, and these 2, would add to 1. So each pair would add to 1. So pause the video now, complete the tree diagram, and then calculate the probability that she wins exactly one game. Okay, so hopefully now you've had a go at that one. If we just run through how we would complete the tree diagram, if it's probability she wins is 0.3, the probability she does not win is 0.7, which you can calculate by doing 1 minus 0.3. The probability that she wins her second game is the same, so both of these would be 0.3, and the probability that she does not win would also be the same, so that there would be 0.7. Now we're asked to draw a tree diagram and find the probability Rachel wins exactly one game. So underneath I'm just going to say the probability she wins exactly one means that she either wins and then does not win, or she does not win the first game and then she wins the second game. So she wins once in both of these scenarios. So the probability that she wins and then does not win, 0.3 times 0.7 is equal to 0.21. The probability she does not win and then wins, 0.7 times 0.3 is also equal to 0.21. So the probability that she wins exactly once is 0.21 plus 0.21, which would give you a final answer of 0.42. Okay, we'll have a look at one more example together, and then there's another your turn question for you to have a go at a little bit later. So example 2, there are 4 red sweets and 3 blue sweets in a bag. Ella takes out a sweet at random, records its colour, then puts it back in the bag. Then Ella takes out another sweet at random and records its colour. And so we're asked to complete a tree diagram. So here, she could either pick a red sweet or a blue sweet. She puts that back in the bag, so there's then exactly the same number as when we started. And she could then again either pick a red sweet or a blue sweet, or a red sweet here, or a blue sweet here. Now to calculate the probability, we're told there's 4 red and 3 blue sweets in a bag, so there are 7 sweets in total. So the probability of choosing a red sweet here is going to be 4 out of 7, and the probability of choosing a blue sweet is going to be 3 out of 7. And we can see here that 4 over 7 add 3 over 7 does add to 1, because 7 over 7 is equal to 1. These probabilities are the same on the second go, because the sweet was replaced. And so, sorry, that should be a 7. And so my completed tree diagram should look something like this. I'm then asked to calculate the probability that Ella picks 2 red sweets. Now if she picks 2 red sweets, she picks a red sweet here and then a red sweet again. So we're going to be timesing these two together. So 4 over 7 times 4 over 7 is equal to 16 over 49. And that's the only possibility that she could do to pick 2 red sweets. None of the other branches would satisfy that, so the answer here would be 16 over 49. Calculate the probability Ella picks no blue sweets. Well, to pick no blue sweets, she has to pick 2 red sweets, because otherwise she's picked a red and a blue and a red, or a blue and a blue, and all of those other options include a blue sweet. So if she picks no blue sweets, that's the same as picking 2 red, and that's exactly the same as the probability we found above, which here would be equal to 16 over 49. Okay, having a look at the your turn question now, we've got there are 6 green counters and 4 yellow counters in a bag. James picks 1 counter at random, records its colour, puts it back, then picks out another counter and records its colour. Complete a tree diagram. So again, if I just quickly show you what that will look like, he can either pick a green counter or a yellow counter on his first turn, and then on his second turn those options are the same. and use what we have done above to help you calculate what those probabilities there would be. So I suggest you pause, have a go at completing the tree diagram, and then read through and complete part B as well. Okay, so hopefully now you've had a go. So if we just run through what this would be, 6 add 4 is 10, so there's 10 counters in total. So the probability of picking green would be 6 out of 10 in all of those cases, and the probability of picking yellow would be 4 out of 10. Calculate the probability that James picks 2 yellow counters. Well, 2 yellow counters would mean he picks a yellow and a yellow, so 4 over 10 times 4 over 10, which is equal to 16 over 100. Sorry, that's meant to be up here, that's part I. But the probability that James does pick no green counters is the same answer as the probability he picks 2 yellow counters, because otherwise he picks a green then a yellow, so he's picked a green, or a yellow then a green, so he's also picked a green. So the probability that he picks no green counters is the same, so both of these answers here would be 16 over 100.